Here we go. So what we're going to talk about today is we're really going to talk about inverses, okay? So we're going to look at one function, just one function, and we're going to find the inverse of that function, okay? So the first thing you need to know is that f of x equals x or y equals x. That's a line, and either one is going to work for you. But you just have to remember that f of x and y, they kind of mean the same thing. X is your domain, f of x or y is your range. And then you need to look at this example. I want you to look at a. So here is a. This is a function, 1, 5, 2, 6, 3, 7. The inverse function would look like 5, 1, 6, 2, 7, 3. What that means is, if I plug 1 into the original function, my answer is 5. Just kind of like we did the -7, right? We plugged in -7 and we got 15. That would be an ordered pair. But in this function, if I plugged in 5, I should get 1. So if I plug in 1, I get 5. In the inverse function, if I plug in 5, I should get 1. That's how we know they're inverses. Like their ordered pairs should be flip-flopped. If they're not flip-flopped, then they're not inverses. So we're gonna talk about that. Okay, so on number 1, so you have 3 problems like this tonight on your homework. I know it's not tonight. You won't probably do it until tomorrow, but it's up there in the video on Schoology. So this one right here, the first thing you need to do is just state the original function's ordered pairs. So the original function's ordered pairs are the ones that they give you. -8, -3, -8, -6, -3, -6. Okay, so this is a triangle. If you graph it, it's a triangle. You can tell, and well, 2 reasons. They give you 3 ordered pairs, and they also tell you that it's a right triangle, okay? Now, the inverse function, I want to show you how to write the inverse function. The inverse function is f, and it has a little -1. That's not an exponent. All that -1 says, this is the inverse function, okay? So I'm actually telling you that these are inverses. So I want you to imagine a function. You plugged in -8, and into the line of the function, you got -3. The inverse function says when you plug -3 into the function, you should get -8. So you should get the reverse order. Then it's -6, -8, and then it's -6, -3. That's the inverse function. So f of x is the original function. The inverse of f is this. So you remember, if you see f raised to the -1, that's not really an exponent. It means the inverse of function. The inverse of f. So I just wanted to make sure you know that these are inverses, that this means right here is an inverse. -1 is not an exponent. The other thing you need to know is that when you graph these, you need to graph y equals x. So anytime tonight, if you have to graph triangles or anything, make sure you graph y of x, because you're going to talk about it. I don't think you have to tonight, but, and the other thing I just need you to know is that when you graph these, it is a reflection over the line y equals x. Okay. So you guys, right here, it tells you a little bit what I just told you about reading the f. You don't really say f to the -1. You see it, but what it means is the inverse of the f function. Okay. Okay. So tonight you have 3 of these. All you have to do is write the original function, inverse function. With the inverse function, you just switch the ordered pairs. Okay. So like I was just telling you, up here in this example right here, so they have f of x equals x minus 4, and the inverse of f of x is x plus 4. If I plug 6 in, I just picked 6, right? It's just an ordered pair, and I put 6 in. 6 minus 4 is 2. So my ordered pair here is 6, 2. That means if the inverse is true, if I plug 2 into this, I should get 6 as my answer. So we plug 2 in. 2 plus 4 is 6. So this ordered pair is 2, 6. So that is why they're inverses. You can do it with any number. If they are true inverses, what will happen is their ordered pair will be switched. If they're not inverses, it's not going to work. Now, not everything is like that, right? And not everything is we're going to switch it and make it negative. So we're going to have to learn how to write the inverse of the function. So what we're going to do is right here, we're going to write the steps to finding the inverse. So steps for finding the inverse of a function. Okay, let's see, there we go. Let us go. Steps for finding the inverse of the function. So the first thing that you have to do, believe it or not, is we need to replace f of x with y. Now I know you're asking yourself, well, if we have to do that, why do they just not write it with the y? I understand, but they're using function notation. So when you use function notation, you need to do this. So you have this original function that they gave you. You're going to take f of x out and you're going to write y. And number 2, step 2, you're going to switch the x and the y. So wherever the x is, you're going to write a y. Wherever the y is, you're going to write an x. Then we did this in chapter 1. We're going to solve for y. So basically we're going to get y by itself again. And we've done this. You do this every time you write a linear equation. You have to get y by itself, or a quadratic equation. We're just trying to get y by itself. Now, you're going to be like, really, Miss Fleury, really? Now we're going to replace y with the inverse function notation. Because now it's no longer the original function, it's the inverse function. And then the last thing that we're going to do, so we actually have 2 parts. The first part that we're going to do is we're going to find the inverse. That's the first part. The second part is we're going to check to see if they're actually inverses. We're going to check to see if you get the identity. Now, again, you guys, I just want to tell you that there's 2 parts to this, okay? We're going to do 1, 2, 3, and 4. That's the first part that we're going to do. And then the second part we're going to do is part 5. But we're going to do part 5 tomorrow. We're only going to do up 1 through 4 today, okay? So we've done, so when you go to do your homework, you'll have the first half of the homework is what we just got done with the ordered pairs in this part. Okay. So replace f of x with y, switch x and y, solve for y, replace for y. And this part is where the graph paper comes in, because you're going to have to graph the original function and the inverse function. You can just make a table if you need to. So I'm going to flip this over. There's some information, and we're going to look at number 1. So find the graph and inverse. Find the inverse of each function. That's what we're going to do. Then graph the function and its inverse. So tonight, you're going to do this part, or tomorrow, and then you'll graph it, okay? So here is the original function. F of x equals x minus 3 over 5. The first step said rewrite it and replace f of x with y. That's the first step. Step 2 said switch x and y. The third step said solve for y. So how do I solve this for y? What do I get rid of? Someone just said it? What? We can't do anything with the -3 yet. What do we have to get rid of first? The 5, because it's being divided by 5, so we need to get rid of that first. So, because it's all over 5, so we're going to multiply each side by 5. So now I have 5x equals x minus 3. Now what? I need to get y by itself, so what do I need to do now? I'm going to add 3 to both sides. And I'm going to rewrite it, you guys, so that y is on the left side, and it becomes 5x plus 3. So that is, this was step 1. This was step 2, multiplying by 5, and this final answer is step 3. And now step 4 says rewrite it, replace y with the negative, with the inverse function notation. So that would be f to negative 1x equals 5x plus 3. So you're going to graph this equation and this equation. That's what you have to do tonight. Okay? There any questions about how I did that? So tomorrow we'll check the identities, but today well, we got one more example to do, you guys. So today it's like switching the ordered pairs and then writing the inverse and graphing it. So number 3, you guys, what am I going to do? I'm going to rewrite the f of x in what terms? So instead of f of x, I'm going to write y equals 3x squared. Now what do I do? Switch them. So now it's x equals 3y squared. Now what? You can't take the square root yet, but we are going to. What do we have to do first? Get rid of the what? The 3. So we're going to divide by 3. Now we're going to do what? We're going to take the square root of both sides. And you know we're not done, right? Because we have to write it in inverse function notation, which is f with the negative 1x equals plus or minus the square root of x plus 3. So you guys, the square root is perfect to do a table with. The lines are perfect. You can do a table with, or you can put them in slope-intercept form. I mean, 5x plus 3 is in slope-intercept form. 3x squared, it's a parabola. You're going to need to remember how to graph a parabola. You can make a table, but you have to make sure you find the vertex in the axis of symmetry, which is good practice since you have an exam coming up. And then the inverse. So tomorrow we're going to check for identities. But for today, I took you through a good chunk of the homework so that you can probably get some of it started if you haven't started it 6.1 yet. So there you go.